find the number of natural numbers between 212 and 999 such that sum of their digits is 15. Now, this is a very interesting problem from permutation and combination. And the general method of solving this problem is to take different cases and then see how many numbers are there in that interval for which sum of the digits will be 15. But here there is another interesting method of solving this problem using coefficient method and then distribution of identical object. So first observation that any number in this interval will be a 3-digit number. So let us say we have the 3-digit number n. On 100 place we have alpha 1, unit 10th place we have alpha 2 and unit place is alpha 3. So the condition is that alpha 1 plus alpha 2 plus alpha 3, this must be 15. Now here first we'll calculate all the numbers starting from 0 up to 999. Right? First we'll find the number of numbers in this interval 0 to 999 and then we'll remove those numbers which are not satisfying this condition. Right? So if I use the coefficient method, I mean here alpha I, right, alpha 1, alpha 2 and so on, this will be a number in this interval, will be either 0 or 1 or 2 or 3 to 9, right? Alpha is a digit, so it will be any one of these 9 digits. And I'm considering all the numbers starting from 0 up to 99, so therefore all of these three variables can take values starting from 0 up to 9. If alpha 1 is 0, that means we have 2-digit number. If both alpha 1 alpha 2 is 0, then we have a single digit number, right? So first let us count all the numbers because that using coefficient method, it will be easy to calculate that coefficient. And then we'll see what are those numbers which are not in this interval, right? So the number of solution of this equation satisfying the condition that these variables are in this interval, that will be coefficient of x raised to 15 n, and alpha 1 can take values from 0 to 9. So x raised to 0, that will be 1, x square and so on up to x raised to 9. Same thing is true for alpha 2 and alpha 3. So therefore this raised to 3, right? That will be the number of solution of this equation satisfying that condition. Remember, we are counting all the numbers starting from 0 up to 999 and then we'll remove the numbers which are not in that interval. And now we can use that coefficient. So this is a GP. Using the formula for GP, it will be 1 minus x raised to 10 raised to 3 and then 1 minus x raised to minus 3. So we need coefficient of x raised to 15n. Now this one you can expand using binomial. So we have 1 minus 3 into x raised to 10 and next term will be x raised to 20. We are interested in coefficient of x raised to 15, so therefore we will not write that term, and 1 minus x raised to minus 3. Now this will be coefficient of x raised to 15n. When you multiply with 1, we have 1 minus x raised to minus 3 minus 3 into, and here we already have x raised to 10, right? We need coefficient of x raised to 15. We already got x raised to 10. That means in this one we need x raised to 5. So 3 into coefficient of x raised to 5 in 1 minus x raised to minus 3. And now for this one we have standard formula. If I need coefficient of x raised to n in 1 minus x raised to minus p, then the formula is n plus p minus 1 c p minus 1, right? N plus p minus 1 c p minus 1. This is the standard formula for finding coefficient of x raised to n in 1 minus x raised to minus p. So here that coefficient will be 15 plus 3 minus 1 c3 minus 1 minus 3 into coefficient of x raised to 5 in this one. So 5 plus 3 minus 1 c3 minus 1. And now this will become 17c2, which is 136, right? 17 into 8 and minus this number will be 7c2, 21 into 3. So 21 into 3, that will be 63. So the total number of numbers that we are getting here starting from 0 up to 999, that will be 136 minus 63, that is 73. But remember, Here we have considered all the values of alpha 1 and alpha 2. So that means we are also getting those numbers which are either single digit or two digit number. All the numbers. So now we need only those numbers which are in this interval. So clearly there is no single digit number for which sum of digits will be 15. So let us find how many two digit numbers are there for which sum of digit will be 15. So one possibility is 96, right? If I take 9 and 6, sum will be 15. Another one will be 87. Next you have 78 and then you have 69, right? If I have 5 here, we cannot create a sum of 15. So these are the only four two-digit number for which sum of digit is 15. Now remember we have to count numbers which are less than 212. So there will be numbers more than 100 also for which sum will be 15. So if I have 1 on 100 place, now we need a sum of 14. So 14 you can create using 9, 5, right? So 195. Then another one you can create 8, 6. Then you have 7, 7. Then you can have 6, 8. And then you have 1, 5, 9. Right? If I have 1, 4, again you cannot get a sum of 15. And if I talk about 200 something, so the biggest sum you can create is 209, right? We can count all the numbers more than 212. So these are the only numbers which are smaller than 212. So total 73 we got, and 73 minus these 9 cases. So therefore, there will be 64 numbers between that interval such that sum of their digits will be 15. So coefficient method is another interesting method of solving this problem. If you take cases, you will get so many different cases. So alpha 1, alpha 2, alpha 3, 15. Then coefficient of x raised to 15 in this expansion. And this will give us all the numbers starting from 0 up to 999. Now remove these 9 numbers because they are not satisfying this condition. So finally the correct answer for this problem will be 64.